find the value of a given integral, we can see that there is t multiplied by some function, and we know from experience that we can try to solve this integral using integration by parts. And to use integration by parts, we need u, v primed, and then find derivative of u integral of v. And in general, we can choose v prime to be ln, and we can find v integral of ln. In general, it can be found. It's not easy, but it's possible. And to find integral of ln, we use also integration by parts. But it will be more useful here to choose u, or we actually can try to choose u to be ln, because we can easily find derivative of ln. It's ln of more complicated argument. We should apply chain rule, and we use rule for the derivative of ln of x. Its derivative is 1 over x, so it becomes 1 over t plus 1, and argument derivative t plus 1 derivative, which is 1. And then v prime is t, and the integral is t squared over 2. And according to the rule, it becomes t uv, which is t squared over 2 ln of t plus 1, and limits 0, 1 minus integral vu primed, integral 0, 1, and we can write a half in front, t squared dt t plus 1. And now let's consider this integral. We can see that it looks like polynomial over polynomial, and we know that for such type of integrals of functions we can do partial fractions. We need split into more simple fractions and integrate. So let's consider t squared over t plus 1, and we can see that the greatest power in the numerator is 2 and the greatest power in the denominator is 1, and polynomial of degree of 2 divided by the polynomial of degree of 1 is polynomial of degree of 1. So it can be represented as polynomial of degree of 1, at plus b plus c over t plus 1. And we can we can make the common denominator, and it becomes at t plus 1 plus b t plus 1 plus c, and then we equate numerators, at t plus 1 plus b t plus 1 plus c, and let's consider some specific values of t so that we can easily find coefficients. So let t be 0, it becomes 0, 0, 0, not 0, so it's 0 is 0 plus b multiplied by 1, so plus b plus c, so b is equal to negative c. And let's consider t be negative 1, so it becomes negative 1 squared. 1 is 0, 0, c, so it's c is 1, hence b is negative 1. And we need a, and let's consider t to be 1, for example, so it becomes 1 is a 1 multiplied by 2 plus b is negative 1 multiplied by 2, and c is 1. So 0, and we can see that a is 1. A is 1. Or I can get this result in another way. I can subtract 1 and add 1 in the numerator. It's the same, but why do I do that? Because I can see that if I split it into two fractions, it becomes t squared minus 1, and t squared minus 1, it's a formula, it's t minus 1 t plus 1, over t plus 1 over t plus 1, t plus 1 cancels, and we get t minus 1 plus 1 over t plus 1. The same result, a is 1, b is negative 1, and c is 1. So our integral becomes, we can substitute limits, so it becomes 1 over 2 ln 2, so it's ln 2 over 2 minus a half, and integral from 0 to 1 of t minus 1 plus 1 over t plus 1 dt, and it becomes ln 2 over 2 minus a half, and t squared over 2 minus t plus ln of the absolute value of t plus 1 and limits 0, 1. And notice that in general it looks like a function of the form ax plus b. So we use the same formula as in data booklet, but there arises 1 over a in front. A is 1 here. Otherwise, you should apply a substitution u in general. And hence it becomes ln 2 over 2 minus a half, substituting 1, we get the next, a half minus 1 plus ln of 2 and minus the lower limit, substituting the lower limit, we get 0, 0, ln of 1, which is 0. And it becomes ln 2 over 2. A half minus 1, it's minus a half, multiplied by negative a half, so it's plus 1 over 4, and minus ln 2 over 2, and hence it's 1 over 4. And it's the required result. So given integral is equal to 1 over 4. And that's all for this question.